Hello, everyone. This is Rashid Feroze, and today I'm going to talk about detection engineering. I believe this is the last session for the day, but I would suggest all of you to hang on for some more time because this is going to be a really interesting session. And I'm pretty sure a lot of you would be able to relate to it, especially if you're working as a defender in your organization. So, we'll be talking about building custom detection controls for cloud native environments using open source and cloud native tools. A little bit about me before we begin. I'm working as a security engineer at Cred. It's a company based out of India, and we are primarily into lifestyle and fintech business. We process approximately 25% of credit card payments in India. I have worked as a security consultant for banks, government agencies, financial entities across the globe in the past. Now, before we move into the topic, I wanted to highlight few points here when it comes to deciding between open source versus commercial or enterprise solution. So there are certain factors that we have to consider. For example, the cost. One of the primary things that we worry about is the cost, and then its support, the liability or the ownership, and then if you want a plug and play version versus we want to build something and maintain it, right? So there are a few trade-offs that we have to consider for each of them. Depending on the context and what you exactly want, you can decide on which path you want to take. Now, here comes the dilemma of the decade for security engineers because right now there are tons of commercial solutions available in the market, right? So, what I've seen is when coming to build versus buy, this is very, very contextual and it depends on the org. What I've seen is basically in an ops first organization, people prefer to buy things rather than build it. And in a tech heavy organization, teams prefer to build solutions rather than buying it. Again, it depends on what kind of tool we are talking about here. Are we talking about a cloud security posture management tool, or are we talking about a SIM solution? So it depends on the context of the tool as well. Now, what we're going to do here is we want to discuss a few questions that you should ask yourselves before going ahead with either building a tool or buying a tool. First of all, is how important security is for your business. Based on that, you might be getting the budget for the tool or building a team. And is that commercial tool that you have evaluated is really plug and play, or you would have to do a lot of groundwork to get that up and running? And the most important part where people miss is basically evaluating whether it actually fill in the gaps or is just giving me a fancy dashboard or a fancy metrics over email. So you wouldn't want to, buy a tool just because it gives you a fancy dashboard. You should check what value it is adding, how much part of the problem it is actually solving for me, and then go ahead with the decision. And then if you are planning to build the tool, then you must ask this question whether your team has the right skill sets to build such tools. If not, then we can hire some such people and build a particular kind of team. And even then, if your answer is like maybe or not sure, then if you can change it to a leaning yes or leaning no when deciding on building versus buying, it will make the decision process much easier. So there are tons of commercial cloud security solutions. I'm talking especially in the terms of cloud, in the context of cloud here, and I've listed a few of them. So this is not the complete exhaustive list. There are tons of open source solution as well. But what I've found in my experience is that for any commercial solution out there, there's an open source alternative. So it might not be working as good as the enterprise one. You might not have support. You might have to build something on the top of it. You might have to maintain that. But there is an open source alternative for almost every commercial solution out there. Uh, Moving ahead, so today we're going to talk about how you can build your own detection controls using cloud native and open source tools. And I'll be taking you through a series of case studies that we have faced in our organization, and how did we build the tools in-house. So these are the three case studies we'll be talking about. The first is regarding how you can use AWS cloud native services such as Lambda to build your own cloud security misconfiguration detection tool. Alternative to this, commercial solutions offer cloud security posture management CSPM tools. And then we will talk about how we can leverage another feature called VPC traffic mirroring, along with open source NIDS such as Suricata or Zeek to gain deeper insights on network traffic and figure out if there is any malicious traffic flowing within my systems. Now, both Suricata and Zeek are open source NIDS. You can download it and get it up and running. Both serve in different use cases. Suricata works on signature matching. If Suricata finds certain traffic matches with its signature that it has in its own database, it will give us an alert. Zeek does something different, and we'll be talking about this in a moment. So, talking about the first use case here, we're using AWS Lambda to build our own cloud security misconfiguration detection. I'll give you some context here before we begin. The problem we were facing here is that the problem we had in front of us was we wanted to detect any kind of changes in our infrastructure in as less time possible as we can, right? And it was getting very difficult to do it via traditional SIEM solutions. And I'll tell you why. So this is the reason we decided to build our own security misconfiguration detection tool, which gives us alert in real time. Introducing Dial. Did I alert Lambda? Dial is just a fancy abbreviation for a bunch of serverless codes that we have written. So if you can see in the picture, it is pretty clear what we are actually trying to do here is whenever you perform any activity in your cloud, an API call is generated and all such activity is logged into CloudTrail. I'm talking in specific to AWS. It will be different in different cloud vendors, but the concept would be the same. So CloudTrail consists of all your APIs and activities which is happening in your cloud. And what we have done here, we have used Event Bridge to actually forward all such JSON events to Dial, which is basically a bunch of code written in a Lambda. And Dial would do all the post processing of that JSON event and figure out whether it is a malicious incident or not, whether we want to alert upon this particular incident or not, do some enrichment, the location enrichment, the threat IP enrichment, and then forward the alert to Slack, to email, right? Or to a SIM solution for visualization and threat hunting over a period of time. And it can also forward the alerts to a central incident response tool. So it has given us multiple benefits and it has solved the problem for us. And I'll tell you how. So this is basically the dial architecture when deployed in a multi-account structure. We can easily deploy it in multiple accounts and receive all the alerts stored in one single place. So what are the advantages of Dial compared to existing CSPM solutions, whether open source or commercial, or SIM solutions? So we have covered different services that we use on a day-to-day basis on Dial, which is EC2, S3, IAM, RDS, etc. Now, the advantage that we have here is that since we have built it from scratch, right, it is very, very modular and it allows us to have a very granular control on the kind of alerts we want to be thrown and what we define as an anomaly, right? So what you define as anomaly might not be anomaly for me. So we can modify it to be a very precise manner to make sure that it just spits out the right kind of information. And this is very, very cost efficient compared to any commercial tool because this is invoked only when the events of interest are seen. So this will not be invoked on all kinds of API calls. Let's say somebody is trying to delete bucket or somebody is trying to modify bucket policy, then this will be called. So we can put hooks on all such kind of events for different kind of services, and we can dial will be invoked for all such kind of services, pull out particular pieces of information, combine it together, and send us as an alert. Other biggest advantage we had was the detection time of dial for any malicious activity is less than 5 seconds. And traditional SIM detection time is approx 5 to 10 minutes. The reason this happens because AWS takes a bit of time to actually write that CloudTrail logs into S3 bucket. And the time that we have observed is basically the delay of like 4 to 5 minutes. Now, since we are not pulling the logs and doing a log analysis here, but instead we are actually just forwarding the events as soon as it happens to our Lambda, detection time reduces drastically, and it's approx 3 to 4 seconds for now, almost in real time. And yes, it is completely stateless, infinitely scalable. We can deploy it in multiple tens of different accounts and very, very cost effective. So, what I wanted to highlight here is that this is the difference between building versus buying. At times, enterprise tool might work for you, but at times it might not. And if it doesn't, then don't worry, to go in that direction and build that tool. So this is the outcome of die, the kind of alerts it throws. It's just a very few ones that I have put here. Can't put everything. So the first one on the top left side is with guard duty finding that it has passed over and sent it to us. And then there is security group finding where somebody has added a 0.0.0. And then on the bottom left, there's an S3 bucket which is being made public by somebody, and you can also see how it was made public. We have passed that piece information and put it here, right? Whether it was via bucket policy, whether it was via an ACL. So this was via an ACL. And then on the bottom right, if you see, somebody created a VP peering outside credit infrastructure, right? So, as the organization grows, there are tens of people working with tens of different teams, and it gets kind of difficult who is doing what for what use cases. So, Dial helps us to monitor everything at one single place and keep a hawk eye on all such kind of changes which is made in our infrastructure. So, this was about using Lambda to build your own cloud security misconfiguration detection tool. Now, we'll move towards how we can leverage this feature called VPC traffic mirroring to gain deeper insights within your network. So let's talk a bit about what is VPC traffic mirroring first. So it's a feature provided by AWS, which you can use to copy network traffic from an Elastic Network interface to another ENI, Elastic Network interface. Right? So, in a nutshell, basically, you can copy any kind of traffic flowing through any network interface to a different instance, right? So, if you can see in the picture, on the left hand side, there's a traffic mirroring source A, on the right, there's a traffic mirroring source B, and in the middle, there's a traffic mirroring target D. Now, what traffic mirroring allows us to do is to copy all the to and fro traffic happening in A and B to D, right? So this is what it is about. And I don't see a lot of people using it, but it's a very amazing feature that we can leverage to gain, deeper insights into our network. So how it works? We are using traffic mirroring from selected instances and not everywhere. And we are forwarding that traffic to an instance. And we are running this open source NIDS such as Suricata or Zeek, which is basically listening to all the packets mirrored from this instance and generating certain set of logs based on the configuration and the rules that we have defined. And then you can also push the Suricata or Zeek logs to Elasticsearch or your favorite SIEM solution for visualization or analytics. So coming to why do we even need Suricata? Why have we chosen Suricata? So it's a very powerful open source NSM, a highly performance and highly scalable one. Uh, it has default protocol parsers. For example, it can parse HTTP, TCP, DNS, all kind of different protocols, and it generates different set of logs for these protocols. Then it also has file extraction and logging capabilities. For example, if somebody is transferring a piece of malware within your network, Suricata would be able to make a local copy of it by analyzing the traffic, and then later on you can do some sort of malware analysis on that particular piece of file. It also has commercial rule sets available. You can build your own rules to detect anomalies. So basically, it works on signature-based detection mechanism. If it finds a traffic which matches a signature pattern, it will give you an alert. And the output here is JSON, which means it will be very easy to push this JSON output to any of your SIEM solution or Elasticsearch. Now, let's talk a bit about why have we chosen Zeek. Again, both Suricata and Zeek are open source NSM, but they both serve different purposes. So Zeek turns your raw traffic into a very intuitive uh, logs, which is very, very powerful for threat hunting. Or we can do some post-processing of those logs and get some very juicy data out of what's happening within your network. So any kind of uh, traffic which is flowing in is captured into a series of events, right? For example, let's say somebody transferred a piece of malware from point A to point B. So if you look at the VPC flow logs, right, network logs, what you will see is you will see an individual TCP packet bytes distributed across thousands of log lines, and it would be very difficult for you to make sense of that. Now, what Zeek does, Zeek combines all of that into one single event into its log and says that this is the source, this is the destination, this is the number of packets that was transferred, this is the number of bytes, the port, the protocol, etc. And then you can analyze that particular Zeek output and do all sorts of analysis over it. So how have we solved for this? What exactly we have done here? We have used VPC traffic mirroring in AWS to forward traffic to a chosen destination from selected instances. Uh, so we are using here Suricata and Zeek both, which are serving different purposes. So they consume the mirror traffic and give us some useful info. So Suricata analyzes the network traffic and detect any attack patterns if there is a signature match. And Zeek performs network inspection and gives us key insights on network traffic and also detects network anomalies. These anomalies has to be defined by us. It does not detect anomalies by default. So this is the architecture, what it looks like. So you don't need to forward the traffic using traffic mirroring from every single instance. You can attach or use traffic mirroring on a selected ENI, which is Elastic Network Interface. It could be your VPN server, it could be your load balancer network interface, it could be your container orchestration network interface. For in our case, we have done this on the VPN server that we are using for our employees to connect. The reason we have used our VPN server in this particular case is because since COVID, our entire workforce has moved to work from home, and everybody has to connect to our VPN to access our infrastructure. And we want to keep a close eye on it as what kind of data or what kind of network is flowing to and fro from here, right? Considering that all our employees are working remote and their systems might be compromised or things of such sort might happen. So if you can see in the picture, we are forwarding all the VPN traffic to two different instances, both of which are running Suricata. And Suricata is running its own detection algorithms on those packets and detecting any such attack signatures. And that is being forwarded to Elasticsearch for visualization. And we're also getting an alert. So this is how the architecture looks like in our context. It might differ in your organization, or you might do it in a different manner. So here are some use cases uh, for your purpose. We can use VPC traffic mirroring for your key hosts and not every host. As I said, you don't have to use this particular feature for like every host out there. Uh, and then you can analyze the network logs based on your network activity, right? So what could be the detection use cases? The use cases could be infinite. It completely depends on your context. What we have used it for that I'm going to discuss today. First of all, it will detect any kind of attack on VPN instance or any kind of malicious traffic flowing through the VPN, right? Let's say if some employee or some attacker is trying to attack our internal infrastructure, right, using the same channel, then we'll be able to detect that. It also detects any kind of zero-day attacks in VPN instance that we're not aware of. We all saw a lot of zero-day attacks since COVID started on the VPN systems because that was an easy target for attackers to get into your infrastructure. And then we have used Zeek to detect any kind of mass data exfiltration happening from our VPN or from our infrastructure. So let's say we have seen a couple of data breaches this year, not a couple of, but a lot of them, yeah, and gigabytes, terabytes of data being stolen, right, without alarming the security team. So we have built uh, a tool called DataHawk using Zeek, which can detect such kind of mass data exfiltration. And then we can use open source tools such as RITA by active countermeasures, right, which can ingest Zeek logs and detect C2 beaconing. So this is an open source tool, very easy to use and very intuitive output. So for starters, this is the kind of output Zeek generates in the file called con.log. It generates different kind of log for each protocol. And if you see, it has all the juicy info, right, which it has found out after tapping to that particular interface, right? Now we can do all sort of things using this information, and we can build whatever tool we want to build further on the top of it. So these are the alerts generated using Suricata. If you can see, someone has tried a remote command execution Netgear one onto our VPN systems, and Suricata has detected it as an attack and thrown the alert. And then somebody is trying to gain privilege access, web application attack, etc. So this is how the signature-based detection works in Suricata. Coming to Zeek, so this is how it works in Zeek, where if you can see this particular alert, it detects any kind of data exfiltration via our VPN. And if you see a particular user has downloaded 8 gigabytes of data from a Redshift, right? We know his or her location, we know their MAC address, we know how much data they have downloaded, uploaded, so that we can piece it together and form a story if an incident happens. And we can investigate whether this is a legit data pull or not. So this is C2 beaconing detection using RITA, as I earlier talked about. RITA is an open source tool which you can find on Active Countermeasures website. And this is a screenshot from the same source, which is active countermeasures. And if you can see at the top line, the top one, there's a score of 0.9997. So basically, RITA scores from 0 to 1 when given Zeek logs, right? So what RITA does is it ingests all the Zeek logs and gives you this kind of information. Now, if you can look closely uh, on the top line, under the connections tab, it says 4,532, and the rest are very low, right? You can also do some analysis on what kind of IP it is, what kind of domain name it is, and come to a conclusion whether it is a C2 beaconing detection or not, right? So your antivirus or your IDS might miss a very complicated piece of zero day, right? What happened in SolarWinds situation, where big companies like Microsoft fail to detect C2 beaconing for a particular period of time. So you can solve that problem if you can use such kind of tools and send alerts or do some sort of post mortem on that. So there are a couple of alternatives to VPC traffic mirroring. It's not only limited to AWS. So in GCP, you will find this feature called packet mirroring. In Azure, there is virtual network tab. This feature was launched, I think, 1 year ago. And then if you're not on cloud, you can use port mirroring or SPAN, right, with your switches. If you are on on-prem infrastructure and do the same kind of setup that what we have done here. Moving to conclusion of the talk, the takeaways. The first question is you need to finalize whether you want to build a particular solution or buy it. What you can do is you can start evaluating commercial products, you can start evaluating open source products, and maybe you will get some sort of learning from there which you want to implement it while building your tool. You need to consider trade-offs for each one of them. Every single time, building is not the right option. It is very contextual. You need to consider trade-off as which one would be giving a better ROI. There is an open source alternative solution for almost every commercial security tool. It might not be as good as the enterprise one, but definitely you will find it if you want to work upon it. So often see people trying to reinvent the wheel when there is already something over there, right? So while building some security solution, try not to reinvent the wheel. Try to use the same components if it is already available. If somebody has already done some job, do some research, figure out open source tools, and maybe you can build on the top of it instead of writing everything from scratch. So I would suggest to use cloud native technologies wherever possible. Very, very important because it makes scaling and deploying very, very easy. Uh, Try to build the product with an aim to open source it. So I believe that you should not build a product which is very tightly bound to your infrastructure because your infrastructure might change at a later point of time and then you would have to redo everything again. So try to cover as many edge cases as possible and try to build a product with an aim to open source it and keep it generic so that other people can also use that. In that scenario, even if your infrastructure changes or you move to a different infrastructure, you'd still be able to use it. A lot of times I see people jumping into building a solution before actually looking out whether we already have an existing solution for that or how other companies in the same space are actually trying to solve that problem. So you can do a little bit of research and trying to find how the companies have solved that problem. Look into open source projects of companies like Netflix, Salesforce, there are tons of them, NCC Group, right? They have open sourced a bunch of very useful tools that we can use. So this was it. Uh, I have attached some references here. We have written blogs regarding Dial as how we have built that and what it serves. And then we have also published one of our blog onto AWS, which you can go ahead and read it here as how we have leveraged VPC traffic mirroring to achieve high level of network inspection. This was it. Any questions? I'll be happy to take it. Thank you.